Okay, so basically, just review about this chapter, right? It's a chapter. We learn about the 3 basic structure. So in every program, you will have the 3 basic structure. You have the sequence, you have the selection, and then you have the loop. So basically, for any program, it's a combination of all the 3 structure here. So spaghetti code, that means when you mix everything together and it's not structured, it's very hard for you to chase down to resolve program. It's, the thing about this one here, everything is confusing because they are not structured for this one. So basically, for every program, you have the 3 basic structure. You have the sequence structure, you have the selection structure, and you have the loop structure. Any program, it will be the using one or more of these 3 structures. And sequence structure will form in the order from the first statement to the next statement until the last statement. Selection structure, you only have the decision to do it, right? So if you have the single alternative and you have the dual alternative also for the selection. And the loop is that keep doing it. And of course, in order to do that, you need to maintain the condition. And if the condition is correct, keep doing it. And if condition is not correct, exit the loop. So you can think about it is a sequence structure. Everything you work in the order from the first statement to the last statement. And now it's a selection here, right? So for this selection, that is a dual alternative. So we have the condition to check, and if it is correct, if the condition is correct, if the condition is correct, that is a problem here. Now I cannot draw. This one. No, cannot.
Can you select the color first?
No, it's not. Doesn't matter. It doesn't matter. Right. Now I cannot draw it. Okay, sorry for that. This one. Okay, so for the selection, right, you will have the condition to check, and if the condition is true, oh no, it's not this one. If the condition is true, you keep do on the one side, right? If not, you do the other side here. Every time I have to either exit pen. I move on. Okay, so here's a simple example, right? When you work with router and so, right? You have the condition here to check start, get the edge from the user and check it edge greater than or equal to 18 or not. And if yes, you are eligible to vote and not yet. It's very, very simple. And so you go look on the again, if you look on the left, it is pseudo code here. On the right, this one is a router and this one with the Python here. Okay, and also we have the single alternative, right? So it's a single alternative. If the condition is true, you do something. If not, you just skip it. Don't do anything here. Right? That is a single alternative here. And you have the loop structure that it repeats a set of action while the condition remains true. Right? Yes, in the loop body, you have called the repetition or iteration here.
We can't see the PowerPoint on Zoom.
You cannot see it.
No, it shows a folder with your PowerPoint things, slides, but no, it doesn't show the actual PowerPoint.
Can you
Okay,
see?
now, yep, that's it. Thank you.
Okay. Sorry about that. So if you look on this one, here's a loop, right? So here's a loop here. For this program, it keeps asking people to enter the number, user to enter the number, and for each iteration of the loop, user print out the double that number, right? So if you look on this one here, if you look on this one, this program is structured here, right? The thing is that you see, you have a prime input here. Oh, it works now. You have a prime input here, right? You have the prime input here before the loop. I remember that prime input is something you get ready for the loop, right? And you see the condition of the loop here is a check if the my number equal to 0 or not. Right? For that reason, you need to get the number before the loop. That is the prime input, or sometimes it is the same with housekeeping here, right? You need to get something to get ready for the loop. And that's why you have to get a number, enter the number to exit here, to check the condition if number equal to 0 or not. If yes. Now remember one thing I have to remind you, okay, the difference between the Raptor and the real programming language. Right? So in the real programming language, we see if the number is not equal to 0, you keep doing it until the number equal to 0. But you see in the Raptor, if the number equals 0, you exit it. Right? So that's why you have to remember the difference between the Raptor and the real programming language here. And normally in the pseudocode, they work with the real programming language. Right? So for that reason, when you convert from pseudocode to the Raptor, you have to make sure you understand the difference here to change the condition. Right? Okay. So see, this one is structured, right? You have the prime input, you check the condition for every iteration, you just time it and print it out. And now see, at the end of the loop, you need to get the new number for the next number here in order to do with another iteration here, right? So the same with this one here. You can think about this one. You have the prime input here, or you have the housekeeping here before, right? You check the condition. You do everything with this one, and for the last, for the end of the body loop, you need to get the new number in order to do with the new iteration here, next iteration here, right? Now I cannot clear it. This one. How can I move? Okay, so we see the loop structure. If you look on the pseudocode, you always see the Y. Whenever you see the Y, it's a loop structure, and whenever you see the if, it is a selection structure in the pseudocode. So basically, for every program, it is using the combination of both of the three structure here: sequence structure, selection structure, and loop structure. You can stack structure together, that put it on top of together, right? Or you can net them together, whatever it is. You have many ways to process one, right? So for this one, you see, for this one here, you see, if you look on this structure, right? You see, you have this one is sequence. Everything is sequence. Now you do the selection, and later on you have the loop. This one is stack, right? They just put it on top of together. Sometimes you can put it inside each other. They call it a netted structure here, netting structure here, right? So see for this one here. This one, you have the put everything sequence here inside the selection. Huh? So, okay, see, this one is a selection here. So what about this one? What do you think? What about this one? What is the structure of this one? Can you tell me what is the structure of this one? What is the structure of this program? Can you tell? Tell me?
Loop inside of a sequence, inside of a selection.
Yeah, right. So in order to understand about the structure, you have to go from the inside inner to go to the outer. So see, you have for this one, you see, for this one here, this one's a loop, right? This one's loop. And you put it inside the sequence, and you see sequence here, you put it inside the selection, right? That's the thing. Okay, so for this one also, right, you have the selection inside the loop, inside the sequence, and inside the selection again. So basically, that is every program, right? Every program use a combination of all the three structure, and structure program has the following characteristic. It includes only combination of three basic structure. It's only right, and each structure has a single entry point and a single exit point. It cannot overlap together, right? Otherwise, spike is put here. And structure can be stacked or connected to one another only on the entry or exit point, and any structure can be netted within another structure. Now, that is a good structure for programming language. So for any program here, you have a primary input. Right? That's what I explained it to you. That there is the first input of the data record. Right? It must be outside the loop, before the loop, right? And to have keep the program structure. And align flowchart structure one step at a time. Watch for unstructured loop that not following order. Think about this one here, right? You think about this one. What's wrong with this program? What's wrong with this program? What do you think? What's wrong with this program? If you look at this one, tell me what's wrong with this program? What's wrong with this program? Let me correct this one. Think about this one is keep answered. Think about you have the file here, right? You have the file here, and in that you have many number, right? And you want to access into the file and read every number in the file and double that number until the end, until the last until the end of the file. Okay, so you see, you can think about this one and the file here. Okay? So you see, access to the first number, think about this one 10, double it, you have the 20. Access to the second one, you have 5 here. You double it, you have the 10, and so on until the last one. Okay, now if you look on this structure, what's wrong with this one? What do you think? What's wrong with this one?
It doesn't call the new number.
Yeah, right. It has the prime input here outside the loop. That's correct, right? And you check the condition here. It's not end of 5 yet, right? So if not end of 5, just double it and print out, right? You done it one number. But if you want to move to the next number, you need to get the new number from the next line here, right? So actually for this one, you need to take action here to put it here, right? Read again, read the new number from the new line here. You got it? Any question for this one? So exactly do the same with the structure here. No, the input, remember that you have the primary input before the loop and outside the loop, right? But at the end of the loop, you need to get the new number. New number here is that means you want to move to the next line here. Next line, next line, next line, until the end of the part, right? So for this one, you see, that one is not a structure. So actually, if you work with this one, it will run it forever with the same number. Right, the same number. So think about you got the number. You think about you got the number 10 here. Print now number 20 again. Print now number 20 again. Print now the number 20, and so on and so on and so on. Right, because it always stays at the first number. Okay. Now, what happened with this one? What's wrong with this one? I explained it on the last class also. What is wrong with this structure here?
It's inside.
Yeah, right. You do not have the primary input inside you do not have the primary input before the loop and outside the loop. Right? So basically, you can do this one with the router, but normally in other programming language you cannot do that. Right? So basically, for this one, you have to move primary input here outside and before the loop, right? And you move this one to the end of the loop here, right? Okay, so here's a correction here, right? You see, if you look on this program here, see its structure here. You got the input. This one is the prime input. To get that into the loop, right? The initial input. And remember that for every iteration of the loop, you need to get the new number. to move on to the loop. Right? This one also, if you were able to do it with Raptor, but not structure, right? So you structure programming to a clarity, right? Unstructured program is very confusing. So if you follow the same rule, right? See, if you follow the same rule, it's very easy for you to do with the programming language. So we think about when you're driving on the highway, you also have to follow the rule here. Professionalism, right? As a programmer, expect it. So we think that when you write a program, when you give it to some other one, it's very easy for him to follow what's going on here because it's structured, it follows general rule here, right? Efficiency, most language supported. Maintenance, another program, quite easier to read. And modularity is that you learn it, right? You break down the complicated program into multiple modules. Okay. Now we don't have to memorize this one. Oh, that's all. Now, see, I want to go back to some of the examples here to show you this one here, right? Okay. That's a selection here, right? That's the selection. So basically, when you work with Raptor, so whenever you want to do with the selection, you have the symbol here. This one is symbol, right? You just and drop it. Right? So for this program, you see, you get the H from the user. Right? You got it from the input, right? Now you check the condition here, H greater than or equal to 18 or not. You do with the selection here, and you drag and drop it and put it the condition here, right? And yes, do the on the this side, and if no, you do on this branch here. Right? So basically, that is where you work with the Raptor in the you work with the selection in the Raptor. For the loop also is very simple here, right? So we see in the loop when you work with the Raptor, you have the symbol here. So loop here, right? And you drag and drop the loop on this one. And remember that for the loop, you always have the condition here to check if the number equal to 0 or not. Right? If the number equal to 0 or not. For this one here. This is the prime input here outside the loop. Check the condition. If no, keep doing it until, and of course at the end you need to get a new number. Right? And if you do the comparison between the Raptor and the Python, you see the Python here. This one, Python. Okay, so see if you look on the Raptor, the Python, you can see what's the difference here. I see on the left, I have the Python. On the left, I have the Raptor, and on the right, I have the Python. So see the difference here is that whenever it's number equal to 0, right? If the condition is true, in the Raptor, you exit the loop. But this one here, if the condition is not true, right? Sorry, if the number is not equal to 0, you keep doing it. It's a Python. But this one here, if the number equals 0, you exit the loop. Right? So that's why if you look on the pseudocode here, the my number not equal to 0, you have to put it here, my number equal to 0 in the Raptor. That is something I want to remind you when you convert from the pseudocode to the Raptor here. Okay, so now I have some other things to do with this one. Now we have the random function, a floor function, and the ceiling function in the Raptor here. So basically, in the Raptor you have the mirror function. In the Raptor you have the mirror function. They call it the random. So the random function is the function generates the random number in the range from 0 to 1. But not include 1. Remember that it's not include 1. It generates any random number in the range from the 0 to the one, but not include one. So we can think about it's a generate number 0 or 0.11255, whatever it is, or 0.9999, but not include one. So that's it here, right? So you can think about when you work with the adapter here, when you work with the function adapter in the Python, you can get it here, right? Think about I have the new program for this one, the new one here. It's assignment. I have X here, and I have random. Guys, see, they have the random here, right? Okay, now I just output the X. Okay, now see what happened here. Run it, right? Now I got this time is a 0.5 something, right? But if I run it again, it's not the same, right? The next time here, so it generates randomly, right? Now think about if I want to do it for 100 for 10 times to see what happened here, right? So I have maintain the loop. I put everything here inside the loop, right? And in the loop here, I have the count, right? So for this one, I want to do it for the 10 times, so that's why I have to maintain the count. 0 for this one, and if the count greater than or equal to 10, I exit the loop. If not, I keep doing it. Now, see, if you look on this program, what do you think about this program? What do you think about this program? I initialize the count. It's a prime input right before, and for every time I check, it's a count greater than 10 or not. It's greater than exit. And for each iteration, I just generate random generate the random number, and I print out the number. What do you think about this program? What do you think about this program? Anything wrong? Anything wrong with this program? What do you think? What do you think? Now, come on. What do you think about this program? Now, see, with this program, right? With this program, I initialize the count number 0. Now, for every time we check count greater than 10 or not, it always stays 0, right? It always stays 0. So it never ever choose. Keep doing it forever. Right? You see, I can run it here. I can run it here. I keep it doing forever and forever. Yeah. And let's look at Anthony here. So see, you can run it here. And you can look on this here. You see, you look on the left, the count always stays at 0. And never ever greater than 10, right? That's why it runs forever. That's why it's run forever for this one. Okay? So see, every time generate run the number here. But I don't know how to terminate this one here, right? So that is a one common mistake when you work the loop. Right? So if you maintain the count here, you have to remember that inside the loop, you have to take action to change the count. Otherwise, it will be the endless loop here, right? So in order to correct it, what I have to do? What do you think? In order to correct it, what I have to do here? What I have to do? I want it to reach to number 10 in order to terminate it. I want to do it for 10 times. So what I have to do? What do you think? What do you think? What I have to do?
Add 1 to the count.
Yes, right. For every iteration of the loop, I just add to the count by 1. Right? So basically, I can change it by I can change my program here. I change it count equal to count plus 1. So see what happened here. I run it. Now count 0, right? Now count 1. Now count 2. Count 3, count 4, count 5, count 6, count 7, count 8, count 9, count 10. Exit. Right? That is a one common mistake when you work the loop here. So, guys, just try to remember that one. Whenever you do the initialize the count, you check the condition, but you need to have action to change the value of the count. Otherwise, it stays the same and never ever exit here. Right? So see, now I do it the 10 times here, right? So we see for each of the time, it generates a random number in the range from 0 to 1, but not includes the number 1. Right? Not includes the number 1 here. Now, you might think that what happens if I want to generate a random number in generate from the, not only from the 0 to 1, but I want to generate random number from 0 to 100. So what I have to do? What do you think? What I have to do? What I have to do if I want to generate random number in generate from 0 to 100?
Tell it to do so.
Sorry?
You have to tell it to generate a number between.
How can I change this program in order to generate a random number from 0 to 1? Sorry, 0 to 100, not 0 to 1. The random function only generates from 0 to 1. Right? So how we do it? So basically you see for this one here, right? For the program, it only the random function only generates from 0 to 1. Huh? And if you want to do it from 0 to 100, for each number you just time it by 100. Right? Just time it by 100. So think about it, generate what 0.58 here, you time it to 100, you have the 58. Right? And if you generate the number 0.99, you time it 100, you have the 99. Right? So you see, now I can change program here, right? I can change my program here. I can change my program here. Now instead of the random here, I time it 100. Now see what happens. Okay, see, I have 69 here, right? I have 40 here and so on. Right? That's it. I just do it at 100. I just time it to 100. Right? Okay, so see, okay, now that is the one action. Now I think you have many numbers that you have many decimal points. Sorry, fractional point. I want to generate the random number from 0 to 100, but it's an integer number. It's a whole number only. I do not anything with the fractional part here. Right? So in thereafter, you can use it in a floor function. The floor or ceiling, you have the two functions here. The floor function. In thereafter, you do the floor function here, and the ceiling. The floor function is always round it down to the whole number, and the ceiling function is always round it up to the whole number here. Right? So think about if I have the number, if I have this 7.55 here. So if I use a floor function here, what do you think? What number I have for this one? 7. Round it down, right? So if I use using ceiling here, I will have the 8. Right? Now what happens if I have the floor negative here? What do you think? Negative 7.75. What is the output of the floor function? For this one here? What do you think? Round it down. Yes, less than, right? You have the less than, right? So actually you have to round it down for this one. You will have the negative 8 for this one, right? You have negative 8 for this one. And the ceiling, you have the negative 7 here. Okay, that is the two functions I want to mention you on this one here, right? On this one here. So basically you see, now the random function, the first thing you have to remember that the random function always generates the number from 0 to 1 only, but not include 1. Right? And if you want to generate, you can add, if you want to generate for the integer number, you have to use the floor function and the ceiling function here, right? So now I can modify my program here. I can modify my program. Now I use the floor function before that. Everything is that one here. Now I run it again. Okay, good, right? You see 75, 47, and so on here, right? It's good here. It makes sense? Any question? Or you can think about this one if you want to make it clear. You want to make it clear, you need one more here, and this one, so this one, you just remove the floor here. Right? So you can see the difference between those. No, sorry. This one. So see, on the top, it is random number, right? With a fractional part, but on, you can see this one here, right? See, I have to do it one more time. Sorry for that. I have to put it here before I round it up. Right here before I round it up. So you see. So slow. It should be better. I run it with a compile. Okay, so see, right? For on the top here is a random number, but when I do the floor function, I just round it to the 767 and so on. Now that is so basically you can use a random number to generate everything from 0 to 1, or everything from 0 to 100, or everything from the 0 to 1000, right? So if you want to generate from 0 to 1000, you just time it to 1000, right? Now what happened? What happened if I just want to generate a random number, iterate with a specific number from the 10 to the 20 here? What do you think? How can I use it? I want to generate random integer number, iterate from the 10 to 20 here. How can I do it? How can I do it? What do you think? How can I do it this one?
Would it be multiplied by 10 and then having 10?
Yeah, right. That's correct. But one more thing you have to remember is that multiply by 10 is not correct. Because from 10 to 20, you have 11 numbers. Right? You have 11 numbers. So basically, you have to time 11, not 10. That is the common mistake again, or another common mistake on this one here, right? Because if you have the 10, actually it only generates everything from 10 to 19 only. 10 to 19 only, right? So for this one here, if you want to generate a random integer number, right? That random integer number from the 10 to the 20, you can use the function here. Now let me change this one, right? You're still able to use the random here, right? And now you know that you need to generate the 11 number, right? That's why we have to count the 11 here, right? The 11, and now you see the starting point is the number 10, right? That's why you have to add the number 10 with this one. And of course, before that, you use the floor function. Floor function, you can use it here. All of this, that's one. This one, I do not the here, and suppose I now I draw eyes, I put that again. To make it short, I do it 3 times. Now see what happened here, right? So see. Okay, see, that's the way, right? That's the way. Or if I want to do it, think about 100 here to see if I am able to catch it for the number 20 or not, right? Yeah, I have number 10 here, right? I have number 10 here. But you see, if I change it to number 10 here, you never ever got the number 10. You never ever got the number 20 here. You see, you never ever got the number 20, right? Because the thing that it only generates everything from the integer from the 10 to 20, but not include the 20. Okay. So now what happened here? What happened if I want to generate the random integer number in the range from negative 5 to 15 here? So what I have to do? What function I have to do if I want to generate the random integer number in the range from negative 5 to the 50? What do you think? What do you think? What's the function here? What's the function here? Any idea? If I want to generate random integer number from the range from negative 5 to the 15, what function I have to use? Now, the first step if you want to generate the random function, the first step you have to find out how many integer number is the range from negative 5 to 15. What do you think? How many number? Negative 5 to 15. How many number? Again, make the same mistake.
21.
Yeah. When you subtract it, you always have to add by 1. I can think about this one here. From the 1 to 3, you have 3 number. 1, 2, 3. But when you subtract 3 minus 1, you only have a 2 here. Right? So that's why when you subtract it, you only have to add by 1. And the same, in order to generate from the 10 to 20, actually you have the 11 number. You take 20, you minus 10, you have 10, you have to add 1. Right? So see, now the first step, you know that for this one, you need the 21 number. You need the 21 number because you have 15, you minus negative 5 here. You have 20, and you have to add 1. You have 21. So we know that in order to generate the 21 number, you have to use the function here, floor. Random here. Random time 21. This one generate every number in range from the 0 to 21, but not include the 21. Okay. Now that's the first step. But you see, you only need to everything from the negative 5 to the 15 only, right? So actually you just minus 5 with this one. And of course, before that, you just want to round it up by the floor function here. That's all. So you see the starting point here, negative 5. How many number? 21 number starting point and the floor. That's all. You just use the combination of all of the thing here. Make sense? Okay. Any questions, guys? Hello? Okay, so basically, you can use the random and floor and ceiling function here to validate the input here, right? So think about this one here. Think about you ask user to enter grade, right? And you expect that grade must be integer number in range from 0 to 100. Think about that, right? And you expect something about everything in the range here from the 0 to 100 away. So we can do with the input validation. Input validation is always the first step in every program. You have to make sure that you got the correct format. Otherwise, after that, you use the processing, you got the crash or you got the error, right? You think about garbage in, garbage out. You got the garbage in, you got the garbage out, right? So think about this one. If you want to get the grade here, you have to make sure that grade here in the range from 0 to 100 here. Right? So whenever you get the grade from answer, you have to check the first step. You check if it's integer number or not, right? Check its range from 0 to 100. All right, but think about this one here. I modify my program. Okay. Talking about and the grade. I also have to do the loop here. That's this one. Put here. The job, right? And store it into the correct. Okay, so now for every time, right, you have to check if the grade here is an integer number format, right? So how we check it? How we check if it's an integer or not? How we check it? Right? So whenever we got the input, I think about whenever you got the input from user, right? You expect something about the whole number here, right? You expect something about 79 or 50 or something, right? So the first step, you have to convert into the floor function to make sure that 50 here actually equal to the floor 50. So if he enters the 50, it's correct, right? But if he enters the 50.5, it's not correct. 50.5 is not equal to floor of 50.5. Right? Because the floor of 50.5, you have 50 here, so it's not equal. Right? So you can check this one here. The first step here, you can do the sequence one here. So you have to check the step here is equal to the floor. Correct or not? Get the floor correct or not? So see, it's correct, right? Correct. You have to enter it again. Think about this one. So what happened here? I enter the number, right? I enter the number 50. It's correct, right? Because the 50 equals to the 50 here. I see. I run it here. Right? Some will say I have a 50. Right? So now run. I got it correct. Right? The condition here is correct. That's why I exit the loop. Right? But what happened here if I run it again? I put the 50.75 here. Right? 0.75 here. So see, it's not equal. It's not equal. That's why ask me again to do it again here. So basically for this one, I have this whether I have iterate and iterate from 0 to iterate in integer format. It's the same as this one. Here, use this one to make it more sense, right? To make it correct, that you tell the user that you have entered in the integer format. Now, but what happened here? But what happened if I enter the number 110 here? What happened? What do you think? Still correct, right? Still correct here. I think about this one. I just bring it down. I do one more action here. See. 110, right? 110. So the condition here to check if grade equal to the floor grade. So 110, of course, equal to the floor of 110. So the program here is correct and print out the grade to 110. It's not acceptable, right? You see, you do not expect this one. You do not expect the program here. Right? So how can you modify this program to make sure that you got the integer number and integrate from the 1 to 100? How we do it? You have to use the compound. You have to compile logic. right? The compound logic here. You know that in the compound logic you have the two table, right? You have AND table, sorry, you have AND table, you have OR table, or you have NOT table. And basically you can use any kind of combination with this one, right? So basically here, I can change this one, right? I can change this one to, I can change this one, I can use a combination here. And I need to make sure that the grade here is not be integrated from 0 to 100 degrees, right? So I can change this one here. And this one. Okay. Well, okay. That's all. That's all. You see. Now check. Check it is in the integer format or not. That's the first step, right? The second one, check if greater than or equal 0 or not, and if less than or equal to 100 or not. Right? You see. Now I run it here. I run this program, right? Right. So I put the 110 here. 110 here. This one is the correct, but the other one is not correct. And you know that the AND logic only true when both of them correct. And if any one of them is not correct, you have the no correct here, and it's asks you to enter again. I see. If I run number 10 here, see, ask me again. Okay, it's not correct. Or if I enter the number negative 15 here, it's not correct. Or if I enter the number 75.8 here, it's not correct. So that is a step. That is one of the very, very simple steps to do the input validation. Now, what happened here? What happened here if I put the number 40 here? I got the 40. Right? I got the error. Right? Because this one is, it packs everything here is in the number format. Right? But if I put the string format here, I got the syntax error for this one. Right? And in the router you have the function you're able to check if the number format or not. And the function, if you want to check if the number format or not, it is number format function. Sorry. Oh. Can you see it now? Hello? Okay. So okay, was this one right? If I enter the 150 here, not correct. Right? If I enter the 15 here, it's not correct. If I enter the 75.8 here, it's not correct. Right? But if I put a 40 here, okay, I got the syntax error. Right? Because this one, see, when you got the 40, it is in string format. And in the string format here, you can use with the floor function. I tell you here, you can take a floor function with the 40. Right? The floor function here is only expect you in the number format. Got it? So basically in the router you have another function here. You can check it. So right now you still cannot see my screen. The guy online.
I'm not on.
Okay, can you see my Raptor file on the screen? Hello?
Yes, I can see it.
Okay, now see if I enter the 40, it not work, right? Because the floor function here It's only accept for the number. So in the router, you have one more function. Build function is the is number here. Is number to check if the you got the input in the number format or not. Right? So see now if I modify this one, if I modify this one here, right? If I modify this one, the first step I have to check. The first step I have to check if it's is number or not. Right? First step here. Yeah, this number variable. I want to check the floor here. Sorry, I want to check right here. And I can add here. So now I will prevent any error with the program, right? To make sure that user have to enter integer number in the range from 0 to 100. Right? You can see. I run it again here. I run it again, right? I run it again. If I put the 40 here, right? See, tell me you have to enter it, right? If I put the number 150 here, again, it tell me you have to enter again. Negative 20 here, again, right? And if I put the 56.7 here, again. Right? And only accept everything in the range from 0 to 100, which is integer format. Right? Think about what happened. 98 equal, right? Print out 98. Okay? Print out 98. Okay? So, I think that's everything about the random function. Right? The first thing is random function, generate everything in the range from 0 to 1, but not include 1. The first step, right? The second one, floor function. The second one, floor function. The third one, it's each number function. And also, if you want to verify if it's a string format, you also have the function each string also. I think about if you want to get the username and the password, you verify that it must be in the string, so we can use each string number, string format, right? So, and you know how to generate a random number in any range, not only from 0 to 1, right? It can be 0 to 100, can be the negative 5 to the 12 or whatever. So, any question so far? Any question? So basically, that if you work on the final project of the final exam, I expect you to do with the input validation here. So whenever you got the thing about you got the salary from one employee, right? You expect that it must be in the number format, and you expect it must be greater than 0. You cannot have negative salary, or you cannot have everything in string. So keep in mind that if you want to have a good program, the first step you only have to do with the input validation here, right? And of course, if you have a garbage in, you have a garbage out. So I think that's all for the lecture. Let me see what we have. This is with the overview. Okay, debugging the system, right? Debugging the system. Yeah. Okay. Now, if you look on this program, now the first thing you have to read on this to know what is the purpose of the program. You have to find out what is the purpose of the program in order to do the zero code here. This zero code is intended to determine whether the student has the pass or fail a course. Student need to have average of the 60 or more on 2 tests. So now I figured out that this program figured out the average. Figured out the average for each student, and each student they have the 2 tests, test number 1 and test number 2, right? and each average greater than or equal 60 plus, if not and, right? And this program here, do it for multiple students. Student number 1, student number 2, student number 3, and so on here. Okay, and now see. Now, if you look on this one, what's wrong with this program? What's wrong with this program? Now tell me, what's wrong with this program? You have to understand about structure here again, right? You have to understand about the prime input. You have to understand about the housekeeping here. So what's wrong with this program?
It's not getting the prime input.
Yeah, right. Now see, what's wrong? The first step here, see, what's wrong here? What's wrong here? The first step here. The condition here to check is that if the first step is not equal to 0, right? If the first step is not equal to 0, right? If the first step here is not equal to 0, I think it's first step here greater than 0. I think it should be better. But anyway, right? Now see, the condition here, the first step not equal to 0, but you do not have anything to get the first step yet. Right? So if you do have this one, when you convert it into the Raptor, or when you convert it to Python, you have the syntax error here. Because program do not understand what's the first step. Have no idea what's the first step, right? So to do this one, the first step, you need to got the prime input. You need to do the housekeeping here. So what is the prime input for this one? What do we need to get from user in order to have the loop run here? What do you need to get from end user to have the loop run?
The first.
Yes, first step. And normally it's the first step of the first student, right? The first step of the first student here. So you can see for this one here. For this one here, right? The first step here, you need to get the input of the first student. Alright. Now move to the while loop. Move to the while loop. What do you have to correct for the while loop here? What do you have to correct for the while loop? What do you think? What do you think?
Should you also add like that it can't be greater than 100?
No. I do not expect it this one. I do not expect it this one. Passing here is a 60 here. So greater than 60 is the pass. Now, what you have to correct inside the loop here? What you have to do is to correct.
You've already found the first.
Yeah, right. See, now each student you need to get the two input. Right? The first one and the second one. Now, for the student here, you only got the first step here, right? You will get the first step here. You do not need the first step from this student only, right? So see, now we got the first step here. Now we move to the second one here, right? We move to the second one here. Right? Now, see, when you got the first step and you got the second step, and you figure out the average, and you check here, the condition here is a selection, right? Check the condition here. If here is a selection, if average greater than passing, then output pass, else output fail. Now, what else? What anything you need to do with the loop here? If you want to move on to the next student, what do you have to do? Yeah, you need to get the test number 1 of the next student in order to do the loop, right? So see, basically for this one here, in order to move on with the loop, you have to get the next one. Now see, you have to understand about the structure of this one. You have to understand the structure of this one. The first step here, it is the first step of the first student. Only first student. Not only first student away. In order to do with the condition here to the test. The first step is the student. Now, the second step here, you see, it is the first iteration, it's the second step of the first student, right? And figure out the average here. The output here, check if greater than. Now, if you want to move to the second student, you need to get the test number 1 of the second student. Or on the next iteration, you need to get the first step of the next student. And it always the structure here. It always structure with this one. If you look again on structure, you can see what happened here. Again on structure here, right? Now see, exactly the same this one. Right? From input, the first number. Right? Do everything. Need to get the next number in order to move on the loop. That's just all. Right? So you understand the structure of the program. It's very easy for you to convert it. Sorry, easy for you to do the debugging exercise. Any question? Say, here's the say. This program, right? Intend to display employee net pay value. Employee have the standard of 45 deduction from the check. If not earned enough for the 45, right? The error will be displayed. That's all. You think about this one. You do it for multiple employees. Huh? Multiple employees. Now, if you look on this program, you have to do it for multiple employees. You have to do it for multiple employees. So what do you think? What's wrong with this program? What's wrong with this program here? What's wrong with this program? You keep doing it until you enter the ZZZ. You keep doing it until you enter the ZZZ here. It is a name you want to exit the loop. So what's wrong with this program? Any idea? What's wrong with this program here? So basically, it's just to see, you do it for many employees, right? Do it for many. So what's wrong with this program? Any idea?
The output input should be inside of the while. No.
Now, if you look on this structure, what is the step here? What is the step in this structure? What do you think? What's the step? Prime input, right? Prime input. A prime input here is a prime input. You got the first name of the first employee, right? And after the prime input, what do you have? After the prime input, you need to do with the loop, right? In order to move on to the multiple employee here, right? And now, if you want to do the loop, you have to do the while here. You cannot do with the if here, right? You have to do with the while. While is the loop, right? So basically, you have to change this one into while here. Now, the while here. You check. You got the name already, right? Check the name is not equal to ZZC. Keep doing it, right? So now you got the hour here. You got the rate here. You figure out the gross. You figure out the net here, right? The net here, and of course, if net greater than 45 on again greater than or equal to 45, you deduct the 45. Right? If not greater than or equal to 45, if print now deduction is not covered net 0. Now, how we have to correct for this one? I tell you if here. I tell you if net greater than or equal to 45. If not, right? So for this one, you cannot use the y here. Got it? You have to use the selection here. Right? You have to use the selection here. So that's why you have to check the if here, right? And if and else here. And of course, this one is you do have the and y here. And y here is this one here. You have an if here. You have an if here, and you have an y here. Right? Sorry, you have an if here. And of course, you see, when you're done with one employee, in order to move on to the next employee, you need to get a new name of the next employee here. Right? Makes sense? Structure always the same. So basically, for this one here, you see, you have a selection inside the loop here. Right? You read for every single employee. Got the name. Check if the name is not equal to ZZC. Keep doing it. Right? Now, check, got the hour, got the rate, figure out the gross, figure out the net. Now, after the net, you do the selection to check if, you see, I'm talking about the if here. If the net greater than or equal to 45, you deduct it, right? not in that case. Alright. Oh, sorry, if net greater than 0, this one actually you already deduct it here already. You deduct it here already. Right? So if the net greater than 0, you print it out. If not, you change it to 0, right? You do not have enough to deduct here. And you move on to the next one here. So it makes sense. Yeah. So at visualizer help you to correct the 2 problem only. You have to figure out the remaining 2 here. Right? Any question? Hello? Okay, so I think that's all, everything about the lecture and the pseudocode also. So if you have any other question, let me know. Otherwise, I just check the attendance here. Right? Again, if you need any help from me, if you need anything with the homework or pseudocode, anything, just let me know. Zachary Baker, Baker, are you here? Hello? Baker, not here. Dial here. Cameron, are you here?
I'm here.
William. Richmond, are you here? Okay. Emiliano, are you here?
Here.
Okay. Riley, are you here? No. Kaden, are you here?
Yeah, I'm here.
Zasmine, are you here?
Yes.
Look, are you here? Look. Diego.
Here.
Okay, Nick, are you here? Jack, are you here? Jack? No. Jose. Hello, Jose, are you here? Martin, are you here? Anthony, are you here? Nathan, are you here? Nathan. Aiden, are you here?
I'm here.
Okay. So I think that's all. We have plenty of time, and if you need any help from me, just let me know. I cover more than the lecture I do with the input validation, random function, raw function, is number function, is string function. Okay. Okay. So if you do not have any question, I will end the class now and see you on. Let's see you on next Tuesday. Bye, guys.